Steve here with a fun trigonometric problem. So we are given the cosecant of a equals negative 13/12, which is right here. But notice for a, there's a range from 3 pi over 2 to 2 pi. So let's pause for a second there and realize, where is this? This is in quadrant 4, okay? So notice that my angle A here is in quadrant 4. And for the second one, the cotangent of B is 4/3, where B is between pi and 3 pi over 2. So where is this? This is in quadrant 3. So let's pause for a second. And I have up here some trig identities. These are the sum and difference formulas. And actually, this is what they're looking for, sine of a plus b or cos of a minus b. So these are here. And since we have a cotangent, let's talk about that in terms of adjacent over opposite. And we also have cosecant, which is 1 over sine, and sine is opposite over hypotenuse. Now looking here, what we're going to want is the sine and the cosine. So just as a reminder, cosine is adjacent over hypotenuse. Okay, so let's go back over here. Let's start with the A here. So notice that this region of this angle A, it's negative 13/12. So since it's in quadrant 12, and if I look at the cosecant function here for sine, it's opposite over the hypotenuse. So this angle here, it's the opposite over hypotenuse. So notice the hypotenuse generally it's non-negative, and notice that there's a positive on the x direction and negative in the y direction. So I have, when we have the negative 12/13 for sine, what we need to do is make sure we put the signs in the right spot. So I can use the Pythagorean theorem right here and solve for this side. So C in this case would be 13, and then A would be negative 12. So I could solve for this B, and that comes out to be 5. So let's go over here. And now for B, we're given the cotangent, which is the adjacent over opposite, and that's got to be 4/3. Well, notice that 4/3 is kind of the same as -4 and -3, because the negative signs cancel. So the key here is to make sure you're not in quadrant 1 when you think of 4/3, because then you'll be off by 180 degrees or pi. So again, using the Pythagorean theorem, this will be a 3, 4, 5 triangle. Now I have everything I need to start putting together the sine and cosine functions relative to these angles. And so sine here, now that I have every part of my triangle, sine is what? Sine is opposite over hypotenuse. So the opposite is negative 12. The hypotenuse is 13. And for cosine, it's adjacent over hypotenuse. So that'd be plus 5 over plus 13. I can now do the same for the b over here. And so notice sine again is opposite, which is negative 3 over hypotenuse 5. And cosine is adjacent, negative 4 over hypotenuse, which is 5. So that's going to be the key, is make sure you're in the right quadrant so you get the right signs. Okay, and so now I have everything I need, my sine A, cosine A, sine B, cosine B, etc. I just now have to figure out these formulas. So the sine A plus B, I take my sine A term, which is the negative 12/3. I take my cosine of B, which is negative 4/5. I take my cosine of A, which is 5/13. And finally, my sine of B, which is negative 3/5. Notice there's a common denominator. 13 times 5 is 65. And here on the left, negative 12 times negative 4 is positive 48. And then here I have 5 times negative 3, which is negative 15. So 48 minus 15 is 33. So this first one, sine of A plus B, will be 33 over 65. Similarly, we can do this for cosine of A minus B and do the right substitutions as you see here. Similarly, we're going to get the same denominator, 65. And here we have 5 times negative 4, which is negative 20. Negative 12 times negative 3, 36. 36 minus 20 is 16. And those would be the answers. So a sort of an alternative or a quick check on this, you could actually solve for this angle if you have a calculator that can do the inverse cotangent of 4/3 and make sure that that angle is in this quadrant. Similarly for A, and then once you have A and B, you could actually substitute those in here and solve for sine and cosine as well. My guess is this is what they wanted you to do. Thanks for watching.